Example 5 looks like the triangle, looks like we're dealing with the right triangle, Pythagorean theorem like the last problem. We're going to go ahead and read through this and see how this problem is different. It says a television camera at a ground level is filming the liftoff of the rocket that is vertically rising according to the position S equals 50t squared. So the rocket's lifting off, and this camera's pointing at it, so the camera obviously has to keep on going up and up and up and up to be able to film that rocket, right? So it says where S is measured in feet and T is measured in seconds. The camera is 2,000 feet from the launch pad, so this is a fixed length right here. It says find the rate of change in the angle of elevation of the camera 10 seconds after liftoff. So what's the angle of elevation? What they're talking about is what angle do I need to point the camera at to keep the rocket in focus? And notice that angle is going to change, and change. So let's look at what's given and what do they want, and then what's our equation. And we're going to have to determine an equation, right? This problem's not near as easy as the previous problems, so we're going to have to be a little careful here. So the first thing I want to note as I'm reading through it is it gives me S equals 50t squared. And the second thing that I notice is they give me t equals 10. So that's going to give me a lot to work with. It gives you more than you think to work with. Let's think of why. If I know what t is, then I can find out what s is, right? So we know that s would be equal to, at that moment in time, 50 times 10 squared. So that tells me that s equals 5,000. That also actually is going to give me a rate of change too. Because if I look at s equals 50 t squared, and I take the derivative with respect to t of both sides, I would have ds dt, which is s prime, right, would be equal to, well, what's the derivative of 50t squared with respect to t? With respect to t, since the variables match, it's just 100t. But don't I also know what t is? Isn't t equal to 10? So s prime would be equal to 100 times 10. So s prime would be 1,000. So what given information do I have? I know what s is, and I know what s prime is. Very, very important information there that you had to work for. None of those were actually physically given to us. The only thing they gave us was an equation for s and a time to plug in. So we had to figure both of those out. What does it want? It wants the rate of change of the angle of elevation. In other words, it wants theta prime. Okay? So let's take a look at this picture, and I'm gonna look at this triangle again. When I look at this triangle, I know here's theta, that angle of elevation. I know this is fixed, the bottom is fixed at 2,000, and we have this side is s. Okay? Think about a relation between theta, s, and 2,000. Well, I know that s is the opposite side of theta, and 2,000 is the adjacent side of theta. So I'm thinking about my trig functions with opposite and adjacent, and I think about tangent. So the equation that I know is tangent of theta is equal to the opposite, which is s, over the adjacent, which is 2,000. So there's an equation that relates theta to s. Remember, I know what s is, and I know what s prime is. I do not know what theta prime is. So let's go ahead and differentiate with respect to t both sides of this equation. Well, what's the derivative of tangent? The derivative of tangent is secant squared theta, but remember now it's with respect to t, so I need the chain rule. I need to say theta prime, and that has to equal, well, the derivative of s is just s prime, and then the 2,000 is just a constant multiple, so that stays in the denominator, right? So it's s prime over 2,000. But I want you to think here, what is secant? Isn't secant really 1 over cosine? So on the left-hand side, don't I really have theta prime is equal to, or sorry, theta prime over cosine squared of theta is equal to s prime over 2,000. Well, let's go ahead and multiply both sides times cosine squared of theta. And let's see what we get. We would have theta prime equals S prime over 2000 times cosine squared of theta. Okay, let's go back to our given information. What do we know? Well, I know that S prime is 1000, so I could plug in, I could plug in for this value right here, S prime, but the problem is I don't know cosine squared theta. Or do I? So let's go back to the triangle at that given moment. We must find cosine squared of theta. Must find cosine of theta and then square it, right? So look at that triangle. In this moment in time, when this is theta, and the bottom is 2000, I also know what S is. Isn't S 5000? So if I want to find out what cosine theta is, isn't cosine theta the opposite over the hypotenuse? Cosine of theta is the opposite over the hypotenuse? Or sorry, adjacent over hypotenuse. Cosine is adjacent over hypotenuse. So that means I need to find the hypotenuse in this situation. Well, how do I find the hypotenuse? I'm just going to simply use Pythagorean theorem. Let me make that an h on that side for hypotenuse. I would know that 2000 squared plus 5000 squared would equal h squared, wouldn't it? Okay, so when I do this, I'm going to go ahead and do this out on my calculator. I'm going to do 2000 squared plus 5000 squared. Hit enter, and I'm getting a big number. It's 290,000,000, and that equals h squared. So if I square root both sides, remember I only care about the positive one here, so I'm going to do the square root of that answer. I'm getting approximately, now we're going to have to estimate this, we're getting approximately 5385 I'll just do 2 decimals, how about 16. And remember, this distance is in terms of what? It's in terms of feet. So that's what h would be. So that's feet. So why do I care about that? Now that I found out what h is, I know that cosine of theta has to be the adjacent, which is 2000, over the hypotenuse, which is that number that I just found, 4,385.16, but then I would take that number and square it. So what do? I take that value right there, 2,000 over 5385.16, I square it, and I plug it in over there into my equation. So theta prime, let me get back to black, theta prime is going to be equal to S prime. S prime was given to us at 1000. So this is 1000 over 2000 times this value that we just solved. We just solved for cosine squared, which was 2000, the adjacent, over the hypotenuse, which is 5385.16 is what I'm estimating it to be, that quantity squared. Go ahead and put that in your calculator and let's see what you get. I am getting approximately equal to 0.07. I'll go to 2 decimal places. Okay. Now we have to think about the rate of change. So what are we measuring? This is the rate of change of theta. Theta is an angle, and remember when we do this, we are always doing our angles in terms of radians. So this is going to be in terms of radians per our unit of time, and our unit of time in this case was measured in seconds. So I'm getting approximately equal to 0.07 radians per second. And if you do what the book did, they left it as a fraction. They got 2/29ths. I don't care. The decimal version of it's perfectly fine. I did the decimal version rounded to 2 decimal places. So if you did that on the test, I would give you credit for either the fraction or the decimal like I did. So not as easy of a problem as the previous problems that we've done. There was a little more work there. We did have to solve for S. We had to solve for S prime, and we also had to solve for cosine of theta. So those were a lot of side steps that weren't directly given to us, but we were able to find. The equation wasn't too hard to find. The derivative of the equation wasn't too hard to find. So a lot of it was really in this problem. The actual calculus wasn't too difficult. It's the setup. Where do I get stuff? How do I plug it in? So hopefully that helps you with that problem. Okay. So this says For the next problem, you will want to remember law of cosines. So what was law of cosines? The idea was Pythagorean theorem only works for right triangles. So what happens if it's not a right triangle? Well, that's where you came up with law of sines and law of cosines. So on this one right here, we're going to be using law of cosines, which is the side b squared equals, that's the long side, right, equals a squared plus c squared, the sum of the short sides, but then you need to subtract off twice the a times c times the cosine of theta. So that is the law of cosines. Would I expect you to memorize that on the test? Heck no, I wouldn't expect you to memorize that on the test. Put that on your note card, and then likely, I'm not even going to lie, it probably wouldn't even be on the test, this problem. But let's go ahead and look at the next problem and see if we can work through it.